let us recall the mid-segment of a triangle. What is a mid-segment of a triangle? So if I have a triangle and I take midpoints of any two sides. So let's say we take midpoint of side AB. So this is the midpoint of side AB. And let's say we take the midpoint of side AC. So this is the midpoint of side AC because it's dividing it into two equal parts. So now if I join these two midpoints, I get a mid-segment. And now let's recall the mid-segment theorem. Well, the mid-segment theorem states that the mid-segment will always be parallel to the third side. So you see that these two lines are parallel. Also, the mid-segment is half the length of the third side. So we see that BC is 36. So mid-segment is this line, which would be half of 36, hence it's 18. So now even if I move this triangle, what you'd observe is that mid-segment, length of mid-segment will not change because BC is not changing. And mid-segment is always half the third side. The third side is not changing. So even if I'm changing my triangle, I'm not changing BC, so the mid-segment is also not changing. So remember that mid-segment is always half of the third side and is parallel to the third side. Now, let us look at this. So say you have this triangle ABC and let's say that D is the midpoint of AB and E is the midpoint of AC. Well, I say that AB is 8 centimeters in length and similarly AC is also 8 centimeters in length. So if AB is 8 and D is the midpoint, then the midpoint divides the side AB in two equal parts. So I can say that BD would be equal to DA. So both of them would be 4 and 4. Since the total is 8, 4 and 4. Similarly, E is also the midpoint of AC. So again, these two lines will also be equal. Since AC is also 8, I can say this would be 4 and 4 again. So now you see that you have a triangle. In the triangle ADE, you have AD which is 4 and AE again which is 4. Now, if I take the midpoint, so this is what you get. This is 4. Now what I do is I take the midpoint of this triangle. So ADE is my smaller triangle. I take the midpoints. So this was 4 and this was also 4. So now taking the midpoint, this becomes 2. And this would also become 2. Again, this was 4, taking midpoints, 2 and 2. Also, since it's a mid-segment that is joining the midpoint, this would be parallel to the third side. So this is what you get, a parallel line and 2. Further, I can take midpoints of this small triangle also, which you see on the top. So let's say these are the midpoints here. And if I join these midpoints, again, I get a mid-segment of this triangle. So now the small triangle, mid-segments of this. Now this was 2. Again, if I take midpoints, this would be 1 and 1. Similarly, this was 2. So this would again be 1 and 1. So what you see is if I keep on applying mid-segment theorem, I get that I get a side of this small triangle also. Now let us focus on just this line and BC. So what do you see? Now this line is not a mid-segment of the entire triangle. It's just one line on this triangle which is parallel to BC. We know that these two lines are parallel. And what you see is that it has divided this triangle ABC into 1 and this is 4 plus 2 plus 1. 4, 5, 6, 7. 4, 5, 6, 7. So what I see is I get 1 and 7, 1 and 7. And this is not the mid-segment of the triangle. This is any line which is parallel to the third side. Now this is precisely what the basic proportionality theorem states. The basic proportionality theorem states that if any line is drawn in a triangle parallel to one of the sides. So if I have this line which is parallel to this, then this line is actually cutting the triangle, the other two sides of the triangle at 2 points. Let's say that these points are D and E. So now if you have a triangle in which one parallel side is cutting the other two sides at points D and E, then basic proportionality theorem states that it would divide the triangle into equal ratios. So you have 1 by 7 and here also 1 by 7. Now let us try to prove this theorem. So we have the basic proportionality theorem, which says that if a line is drawn parallel to one of these sides and it intersects the other two sides at 2 points, then that line would divide the other two sides in the same ratio. So to prove this, first I need is a triangle. So let's say we have this triangle, and let's say DE is a line which is parallel to one of these sides, which is BC. So what I'm given is that DE is parallel to BC, and this line DE is actually intersecting AB at D and AC at E. So these are the things which are given to me. Now what do I want to prove? I want to prove the basic proportionality theorem, which is BPT, and that says that AD by DB would be equal to AE by EC. So this is what I want to prove, that AD by DB, this side by this, should be equal to this by this. So to prove this, how do I begin? So let's draw a line perpendicular to this and call this point as F. So I draw a line perpendicular to AD and I join B and E. So that's what I do. I join B and E and I draw a line perpendicular to from E to the side AB. Now observe this triangle ADE. In this triangle, if I want to find area of this triangle, that is this blue shaded region, then how do we find area of a triangle? It is given by half into base into height. So all I need is base and height. So to find the base of this triangle, now any of the sides can be base. So let us say that AD is the base of the triangle ADE. So if AD is the base, then height is the perpendicular distance from the base to the opposite vertex. So if AD is the base, opposite vertex is E. Perpendicular from the opposite vertex is this line, which is EF. So EF becomes my height. So area of the triangle would be half into base into height. Base is AD, height is EF. So I get half AD into EF. So that is how I find area of triangle ADE. Now let's look at triangle BDE. Now let's look at this triangle and find area of this triangle again. Again, area would be given by half into base into height. Now base, any side, height, perpendicular distance from opposite vertex to the base. So let's say base is DB. In this triangle, let's say base is DB. Opposite vertex is E. Perpendicular from E is EF. So basically you have to extend this side DB. Altitude is outside the triangle DBE. So again, this is my base, height is EF. So area would be half into BD, which is the base, into EF. Let's look at this. So you get half into base into height. Base is DB, this side. Height is EF, perpendicular from opposite vertex. Now you've got area of two triangles. I see a lot of things common in these two triangles. So what I do is, I'll divide these two triangles. Let me see. So if I divide these two triangles here, let's say we divide it, then what you see, EF would get cancelled. It's common in both. Again, half is also common in both. What you would left with is AD by DB, which is AD by DB. So this triangle divided by area of this triangle would give me AD by DB. So if I divide the two, again I can cancel out EF. I can cancel out half. What I am left with is AD by DB. Now this is what you need to remember. This is what we take forward from this. So we know area of triangle ADE, this triangle divided by area of triangle DBE. So this triangle would give me AD by DB. We've just seen this. Now what we do is, now similarly we can repeat the process by joining C and D. Earlier we had joined B and E. Now let's join C and D. So if I join CD, let's say I join CD and I draw a perpendicular from D to the side AC. So if this is my perpendicular, and let's call this point G now. So I joined CD and I draw a perpendicular from D to the base, which is AC. So this is what I do. Now again we can find triangle, area of this triangle ADE. What would that be? Again, base into height, half into base into height. Base can be any side. Now let's take AE as the base. If AE is the base, if this is my base, then vertex opposite to it is D. Perpendicular from D is this line DG. So now area would be half into base, which is EE, AE, half into AE, which is my base, into height, which is DG. So this is what I get as area of this triangle, half into AE base into height DG. Now similarly I can find area of this triangle also. Let's find area of this triangle, DEC. So to find area of this triangle, again I need half into base into height. So I need to find base and height. If I take EC as the base, any side as the base, I take EC as the base. Opposite to this, vertex opposite to it is D. Perpendicular from D is DG again. So for this triangle, area would be half into base is EC into perpendicular height is DG. So this is what I'll get here. Half into EC into DG. Again, you can see DG common, half common. So let's just divide these two triangles. So if I divide these two triangles, I can cancel out DG, common in both. I can cancel out half, common in both. What I had left with is area of triangle ADE divided by triangle DEC would give me AE by EC. Let us see. So dividing the two, again DG common, half common. AE by EC. AE by EC. So we've seen, this is what we'll remember, take forward. So now we've got this. Area of triangle ADE to triangle DBE, which is AD by DB, AD by DB, and area of triangle ADE to this triangle DEC is AE by EC. So this is what we've got. What do we want to prove? We want to prove that AD by DB is equal to AE by EC. So these two expressions should be same. In these two expressions, you see that you have area of triangle AD, DB, DEC. So AD is common in both. All I need to do is prove that area of these two triangles is the same. So let us proceed. What you see is that these two triangles, which is DBE and DEC. Let's come to these two triangles. So this is DBE and this triangle is DEC. So in these two triangles, you will observe that both of them are between two parallel lines. So if they are between two parallel lines, let's say I extend this parallel line. We know between two parallel lines, distance is always the same. Let's say distance is h. So distance between these two parallel lines would always be the same. And these two triangles are on a same base DE. So the base is the same, the height is also the same. Distance from opposite vertex, base to opposite vertex, which is B in this triangle. Again, that is h, height is h. If I see distance of base to opposite vertex in this triangle, then that is opposite vertex is C. And perpendicular distance would be this, which is again h. Between two parallel lines, distance is always the same. So we see that the base is common, height is also the same. So when I have triangles between same base, which have common base and are between two parallel lines, I can say area would be the same. Why is area the same? Because area is half into base into height. Base is the same for two, height is the same for two, so area has to be the same. Now if I have area of these two triangles same, I can say that 1 upon area of these two triangles would also be same. If I reciprocate this, what do I get? 1 upon this is equal to 1 upon this. This is also true. Now, what I can do is I can multiply it by ADE, because that is what I want. ADE by DBE. Again, I want ADE by DEC. So if I multiply both sides by triangle ADE, then again the equality holds. Now you know that ADE by DBE, area of ADE by DBE is AD by DB. Area of triangle ADE by triangle DEC is AE by EC. So instead of this, I can write AD by DB, and this is equal to AE by EC. So what I wanted to prove was AD by DB is equal to AE by EC, and what do you see here? AD by DB is equal to AE by EC. Hence I have proved this theorem. So what we've seen is that in a triangle, if there is any line that is parallel to the third side, then this line would divide the other two sides in the same ratio. So you see that this line is parallel to BC, so it is dividing the two sides of the triangle in the same ratio, that is AD by DB would be equal to AE by EC. So this is the basic proportionality theorem, which can also be called as BPT. So can you answer this question now? We know that DE is parallel to PR and we want to find the length of ER. What I see is a triangle PQR and two parallel lines, that is DE parallel to PR. A triangle, parallel lines, immediately what comes to my mind is BPT. So applying BPT, what I can say is that QE by ER should be equal to QD by DP. So let's write that. By BPT, I can say QE by ER should be equal to QD by DP. Now let's substitute the values here. QE is 8. ER I don't know. That is what I need to find. QD is 6. And DP is 15. So from here, cross multiplying, I can say that ER would be equal to, if I take ER here and cross multiply this here, so I get 8 into 15 by 6. So 4 2s are, 4 3s are, and 3 5s are. I get ER as 20. So ER would be 20. So that's how you can use BPT to solve this.